Well, hello, Internet. In this video, I'm going to show you how to stop losing money in the stock market. How we're going to do it is we are going to add non-correlated assets to our portfolios, and then we're going to verify the systematic as well as the idiosyncratic risk of the portfolio by taking the dot product of the transpose of the weights by the covariance of the total portfolio. And yes, you'll understand that also in this video, and I have a lot to do, so let's get into it. All right, so here we are in Jupyter Notebooks, and what's awesome is we have made so many things in the first 3 videos that we're going to be able to do so many awesome things now using what we've already made. So all of these imports exactly the same. Here are your dates and different constants. Again, for Windows, you're going to have a slightly different path to your stocks file. And of course, I have a link to all these stocks to be downloaded, so you don't have to mess with that. Have all our information in regards to our starting and our ending dates. Here we are downloading all of our stock tickers by accessing the file names. Only use this if you are on Mac. Don't need it otherwise if you're on Windows. There's our function that returns a data frame from a CSV file. We have a function that saves data frames to CSV files. We're able to go and throw in a starting and an ending date, and it's going to kick back to us a valid starting and ending date, which is extremely useful. And then we're going to be able to get return on investments over defined date ranges, get means, standard deviations, coefficients of variation. If you don't know what any of these are, watch the previous video. We're going to be able to merge data frames using common column names. And that brings us to this video. All right, so we are really in search of eliminating risk from our portfolio, and we're looking at all the different ways we can do that. So one thing we can do is we can go and get investments from different market sectors. Now, normally, if you are picking stocks from different sectors, that means that these stocks are going to be non-correlated. They are going to raise or lower in price at different times of the year. So the more of these different stocks we have, the better our performance will be and the lower our risk will be for our portfolio. So what we want to do is I have, again, in the description, you're going to find a GitHub page that's going to have this CSV file, and it's going to have our different stocks and what sectors they are in. And that file looks like this. So we're going to have all of our different ticker names, and it also has the actual company names, which is going to be useful, as well as this sector that they are in. All right, so we have that CSV file. Again, it's in the description. So what I did was I went and plugged in my directory, and I'm going to read those sectors from that CSV file. And you can see here the output of that, all of the things that I would be expecting. So what I want to do now is I want to get data frames that are made up of just those specific stocks in those specific sectors. So let's say I want all of the industrial stocks and I want to throw them into a data frame. Well, I can just go SEC and DF dot location and SEC DF, and I'm specifically looking for the sector for our data frame. See, sector, we're working with the data frame now. And I'm going to come out here and I'm going to say specifically the sector that I am looking for is industrials, right like that. All right, so then I can come in here and go industrial data frame, and boom, and it's going to give me just the industrials. Okay, so I can do this for all of the different stock sectors, and I did so right here. So you could see, you could pause your screen or just get this whole entire Jupyter Notebook. It's in the description. So I have the industrials, health, IT, communications, and so forth. And you could see all of those and how I was able to get all of those from those files. All right, so there we go. Have all of our sectors all in a data frame. Very, very useful. Now what I want to do is I want to get a data frame with all of the return on investments for all of our different stocks. And I'm going to create a function that does this. So I'm going to call this get ROIs for stocks, and it's going to be passed a stock data frame. So there we are. And then what I'm going to do is I'm going to have a list, and what it's going to do is hold all of my tickers. I'm going to have another list, and it's going to have all of the return on investments for all said stocks. And then I just need to cycle through the data frame that's passed inside of it. And I'm going to just go index and row in stock df. And then I'm going to use iterator rows. And what this is going to do is provide both the index as well as the column for each row in the data frame. Okay, so go like this. Then I'm going to go data frame, create a new data frame, and I'm going to call get data frame from CSV. And to do so, I need to pass in the symbol. Well, the way I can do that is to call row and symbol. And then after that, I need to say or check if the ticker actually exists for that specific data frame. So I'm going to say if data frame is none, because the list that I'm using for sectors is from the S&P 500, and the other stocks that we have in our directory come from the Wilshire 5000, and I specifically only want data for stocks that have existed since 2017. So I'm just doing that because I want a lot of data to be able to mess around with. Now at this point, you could print out an error message that says something like that specific ticker is not available or something like that. But in this situation, I'm just going to type pass inside of here, which basically means if DF is none, do nothing. That's basically what pass means in this situation. Otherwise, if it does exist, I'm going to call append, and I'm going to get our stock symbol, right, like this, and append the two tickers, which is our list that we have up here. And then what I'm going to do is I'm going to create a new data frame made up of the tickers and the return on investment lists. Okay. Well, then I need to be able to get my starting and my ending date. So I'm going to go get valid dates and data frame. And in this situation, I'm just going to define a date here, and that's going to be 2018-01, -01. So the beginning of 2018 through 2020-12-31. I normally don't like to hard code things. I'd rather put it inside of here, but whatever. For now, that's what I'm going to do. Then I'm going to say data frame is equal to data frame, and I need to set the index, like I have done numerous other times, to the value that we have for date. ROI, I'm going to call ROI between dates, like this, and I'm going to pass in data frame and the starting date and the ending date. So that will get me the return on investment. And then I can go and take that and append it to my ROIs list. So there we are. So now we got the tickers and the ROIs. We got everything that we would ever hope for in this situation. So what we're going to do here is return a new data frame. So data frame, and inside of it, we want to put a column called ticker, and we want to assign the ticker list that we just generated and put that in that column. We're going to create another column inside of our data frame called ROI, and we're going to put our ROIS list inside of it. All right, so there we go. Now we can go and test this. So I'm going to call this industrial equal to, and get ROIs for stock. Why don't I just copy this, and so let's just copy the whole thing. So let's just throw this right there. Get ROIs for stocks, and then I'm going to change this to our industrials data frame, like that. And then we can say industrial to see what that looks like. And you can see now, not only do we have the industrial tickers, but we also have the return on investment, and we have 66 of those. So that's how easy it is. All right, so let's go get all of the rest of them. And there they are. So I have all of the different stock sectors, and I have the tickers for each of the stock sectors, as well as the return on investment for every single stock sector. All right. So now what I want to do is, let's say, this is how easy it is. Let's say I want to come in and I want to go and get the top, let's say, 5 industrial stocks based off of the return on investment. I can do that. And I can do it over any time frame that I would like, as long as I have the data, obviously. So I'm going to say by, I want to sort by ROI. So ROI, like that. And I want to go and set ascending to be equal to false, because I want the top industrial stocks. I do not want the worst industrial stocks. So let's say I want the top 5. Boom. There we are. I have all of the industrial stocks since 2018 through the beginning of 2021. And GNRC is by far providing the best return on investment. So that's pretty cool. All right, so we have the top industrial stocks, and let's say I want the top 5 healthcare stocks. Boom, there we are, got them. Let's say I want the top information technology stocks. And what I'm going to do here is, in later videos, what I'm going to do is I'm going to go and decide if it's a good entry point by using chart patterns. We have to take steps here. So they're top communications companies. I went and got the top 20 of them, just to show you that you can get 20 instead of 5. Of course, if you only want 5, well, there you are. And the top consumer staples. So there is the consumer staples, discretionaries, and utilities, and finance, and materials. You can see it's just so easy to go and grab all of these different stocks and see what's working, all right? Now, based off of those returns, what I want to do is I wanted to get a stock from each of those individual sectors, and then I want to check to see if they are correlated or not, or if this would be a nice bunch of stocks to throw together into a portfolio, and then afterwards figure out how dramatically I have lowered risk overall versus investing in just one security. Then we'll talk about things like systemic and non-systemic risk and things like that, which, if you know about, make you sound real smart. All right, so what I'm going to do here is I'm going to go mult data frame is equal to, and I'm going to call our function merge data frame by and column name. And I want to merge based off of daily return. Remember, we're investors. We care about returns. We do not care about prices. And I am going to specifically look for 2018-01-01, so the beginning of 2018 through to the beginning of 2021. Okay, so there we are. And if you're wondering why I'm not going the whole way into, present day, it's because at some point we're going to be doing simulations, and we're going to buy our investment, and then we're going to check to see if it was a good investment so far this year. Okay, that's how we do projections and check to see how our investments are doing. All right, so we're going to pass in that portfolio list, this guy right here. So there that is. And then if you want to see it, and go mult df, whoops, port list is not defined. Oh, I just forgot to hit enter there. And here we are. Okay, so there you can see all of the returns for all of our different securities in our stock. Well, what's cool is I can now generate a correlation matrix and see if these are indeed good investments, if our goal is to go and find non-correlated assets. And you can see here, yeah, they're pretty good. All right, we got 0.28, we got 0.39, 0.3s. Remember, we want to get investments that are below 0.5. And for the most part, we have that. And sometimes we have very extreme versions right here. So this is beautiful. And of course, whenever you check correlation between the stock and itself, it comes back as perfect. So that's why that's 1. All right, so there's a correlation matrix. And it looks like we have created a portfolio that should lower risk. And what we want to do now is figure out if it does lower risk. Well, to do that, though, I need to find out the number of samples we have. So what I want to do is I want to find out how many days we have in all of our investments. So I'm going to go length and mult, df, and index. And that is going to tell us the number of total samples we have, which is 756. Now what I want to do is go and create a function that is going to get us a stock price based off of a defined date. So I'm going to go get stock price on date. So it's going to tell me what was the price of that stock on that specific date. And go like this. Go create data frame. I'm going to go get df from CSV, pass in our ticker, and there we are. And df is equal to df. Again, we have to set our index to be based off of the date. So there's that. And then what we're going to be able to do is go return and df dot location, and specifically the date, and what we want it to return is the adjusted close on that defined date. All right, so what I want to do is I want to find out what is the value of these specific stocks as of 1/04/2021. I think that's a good place to start off, and then we're going to go and figure out dates and things, or figure out things like weighting and things like that. Okay, so like this, and then if I want to go and get the stock price on a certain date, I can just go and copy this. So copy and paste that inside of there. So what ticker am I looking for? Let's get this out of here. Well, it's going to be GNRC, of course. And the date that I'm specifically looking for is going to be 2021 and 01-04. All right, so this is going to help me just boom. So the price on the very beginning of 2021 was $224.56, you can say. And you can see here that I went in and I actually plugged in all of the different investments. And then what I want to do is figure out how much of these different investments I should purchase to try to give them a close approximation of equal weighting inside of our portfolio. It's definitely not perfect though. And that's what this part is. One stock for $357. This is going to be 2 shares, okay, based off of it being 224 and so forth and so on. Then if I go and add up all of these numbers right here, we get our total investment. So let's run that up. And there it is, $4,905. So let's say somebody comes into you and says, I'd like you to make a portfolio for me. I have $5,000. What do you got? This would be a pretty, at least a starting off point. Pretty good place to start off. And then we can analyze risk and return and so forth, which is what we're going to do next, to figure out if this portfolio actually provides a good return at a low risk. So there you go. We got $4,905.98 of total investments. So what I want to do now is create another function. And what it's going to do is it's going to give me the portfolio weight. And it does that by just dividing our price by whatever the total size of the portfolio is. So we'll just say return and price divided by total. And that will give me our weight. So make sure that's price, and there we are. So bounce into here. All right, so I went and plugged in all of that data to get the weighting for all of our different stocks. And then I'm going to create a new NumPy array called weights, NumPy array. And then we plug in all of those different weighting values, which we have right here. And if we do that, you can see, yeah, it's not, they're not equal. But we have 9%, 7%, 7%, 10%, 7%. They're in the ballpark. All right, so if we're dealing with a limited amount of money to invest and we're not able to buy fractional shares, this is the type of stuff you get. All right, so it's pretty good. All right, so there we are. Now what I want to do is I want to come in and I want to calculate the portfolio's covariance. So we talked about covariance previously. So I'm going to go portfolio variance is equal to, and we did this exact same calculation in the last video. What do? We get the transpose of the weights, which we do with this, and then we get our dot product. So dot like that, and we get all of our different investments, and we go and call covariance on those. So covariance, we need to multiply by the sample size, which is going to be 756 days, as well as the weights. And if we do so, we are going to be able to get our portfolio covariance, and there that is. And we can output this portfolio variance like that. And there it is 18%. Now, if we compare this to a individual security that we have inside of here. So, and this is investments over 19, 20, 21. Yeah, so this is a 3-year investment. So you have an 18% covariance. That's pretty spectacular because you have to understand a lot of that is upside. So that's a good thing, you know. Okay, so we're going to go and get the variance of, remember, covariance is whenever we're comparing multiple securities. Variance is when we are comparing just one. Okay, so variance from the mean is what we're looking for here with an individual security. With covariance, we're looking at the variance with all the different investments, multiple investments. Okay, so we call variance, and we multiply that times 756, and you can see that is pretty doggone dramatic right there. All right, so what our goal here is to get a fantastic rate of return, but at the same time, not have the investments flying all over the place, scaring the customer, and making them drop out of the market at the wrong time, which happens. All right, now to do this, you have to understand there are different types of risk. There is risk that you can limit through diversification. It is referred to as idiosyncratic risk. Then you have risk that you cannot diversify away. This is called systematic risk, and it is caused by unforeseen conditions such as wars, recessions, natural disasters, dramatic changes in regards to consumer actions, etc., pandemics. These things cause the market to go crazy. We cannot diversify those things, but we can diversify away individual stock risk, okay? And data tells us that if we make a portfolio of approximately 25 stocks that are not correlated to each other, that we basically are maximizing our prevention of risk or lowering of risk. Just 25 securities. That's it. You don't need a gigantic index. But that is why people invest in indexes. But the downside of investing in indexes is that you're not able to take advantage of those returns because you're basically, you're dramatically lowering your returns, and you're picking up 500 different securities whenever you could get that same risk lowering amazing ability by just buying 25 securities. All right. So what we want to figure out is what amount of risk can we diversify away? And we're going to find that by getting our portfolio variance and then subtracting from it all of the weighted variances. So let's do that. And if by chance you are one of the people that are still watching this video, please take a second and tell me, because I just want to know if anyone is out there watching this or if I'm talking to myself. All right, so diversifiable risk. So what this is going to do is it is going to be passed a data frame and tickers as well as weights. So got that. Then what we're going to do is we're going to get the total number of days. This is going to work for any grouping of securities. So I'm going to say length of, and we will call mult df and index. And then what I want to do is calculate the covariance of our portfolio. So let's come up here and let's go and copy this part right here and then just change it a little bit. So I'm going to get this guy and throw it right there. Okay, so let's call this portfolio covariance, and let's go and change a couple different things here. Like this is going to be called weights. That comes from this right here. And we're going to get the transpose of that again. Let's also weights. There we are. And we are going to have dot product. This is just going to be changed to DF. So let's get rid of that. And this is going to be changed to days. All right, so we got all of those things. I think I have everything perfect. Yes, I think I do. All right, so we got that. All right, so now what I want to do is I need to cycle through all of these securities now that I have my portfolio variance, and I need to subtract out the weighted variances of the individual securities. How I do that? I'm going to do it with a while loop, and I'm going to say while I is less than the length of the number of tickers. So I want to find out how many different stocks am I analyzing. And for those, I want to go through, get their individual weighted variances, and subtract them from the portfolio variance to find out my total diversifiable risk. Can you imagine saying that to somebody? They'd think you were a super genius. And it's as you can see, it's really not that hard. All right. For the few people that are still here. Okay, so to do this, what we do is we have to go and square our weight. Remember, the weight is the, let's see here. Well, I printed it out up here. It's how much of the portfolio this individual stock makes up. So we're going to go and we're going to get that weight for that security and we're going to square it. All right, then I'm going to go and get the variance and I call mult TF and tickers and I like this and dot variance. And you need to multiply this times the number of days, if you remember from past videos. So that otherwise, you're just going to get an individual, period. That's kind of worthless. Okay. And then what we want to do is we want to get our weight and variance. And what we do is we go and get weight squared times our stock variance like this. And then we subtract it from our portfolio covariance, which is going to be portfolio covariance like that, and minus the individual weighting of our security, the individual variance of our security. Then, of course, we have to come in here and increment 1, do that for all those different stocks, and then after we do this, we can go and return our final portfolio covariance. All right, so let's find out how much risk our portfolio has that we can eliminate through diversification, okay? And this is so ridiculously powerful. Okay, how we do it is we go calculate. Oh, let's not type that in. I don't feel like typing in diversifiable risk. I don't know about you. All right, so let's go get this, and let's paste this right there. And I'm going to be passing in our big giant list that we have here with all of our portfolios. I also have our portfolio list, which has all of our individual tickers. And then this is just simply called weights up above. And if I go and calculate that, and I didn't make any errors, there you can see we are able to diversify away 0.136, or well, actually it's 13.6% of the risk in our portfolio. So then you may ask, well, how much risk can I not diversify away from my portfolio? Pretty simple to find out. Bonus points if you have any idea what we call the risk that cannot be diversified. It's called systematic risk. All right, systematic risk is what we cannot diversify apart, and how we're going to find out how much that is, portfolio variance minus the diversifiable risk, right like that. Pretty easy. And there you can see we are not able to diversify away 4.59% of that risk, which is pretty absolutely amazing. All right. So hopefully you guys found this video as enjoyable as I did in making. And like always, please leave your questions and comments down below. Otherwise, till next time.